Hello, and welcome to the first Q&A session of the day for session number 4, Performance Management. I'm the moderator, Ariane Jansen, and we are taking your questions from the live stream chat. So if you have anything that's come up over the last few minutes of watching these great presentations, please put them in. Our first question is for David Zhang, coming back to PolarDB, which was our first talk of today. RDMA incurs high costs. Do you have an estimate of per query costs for different use cases? Do you generalize? David?
Thank you for this question. I think it's a great question. I do want to kind of clarify a little bit. So here I assume the cost is referring to costs in terms of dollars, monetary cost. In terms of performance, of course, we all know that RDMA offers great performance over traditional TCP/IP network. Latency, in our experience, one-sided RDMA writes at 4K size, we're seeing 4 to 6 microseconds. So RDMA offers great performance, and latency is one of its great attributes, low latency. So in terms of monetary cost, we believe that it makes up for its development cost or deployment cost in performance. So in one study that we have a workload that goes in 4 phases, and with the PolarDB 3-tier architecture, we can allocate, say, about 7,800 cores to cover the entire workload, whereas without this, in a traditional architecture, we have to allocate 32 cores fixed. So that totals out to more than 13,000 cores. So we see this experiment showing that we reduce monetary cost by 44%. Indeed, every technology deployed in PolarDB, for example, Smart SSD, is also more costly than a traditional, less smart SSD, let's say. But we always go for the cost performance ratio here. And for details, you can check out the paper in VLDB, and cost per dollar, cost per query is definitely better in the PolarDB case. Thank you.
Thank you so much, David. Talking about costs, there's also costs in terms of performance and how performance can, cause problems, or you can have problems when you're introducing new technology. So I'm going to move over to Vahid and ask this question: as by moving the business logic to PHP, you're introducing a new additional remote call. Do you expect this to impact reliability or latency of products with these calls?
Yeah, thanks for the question. In fact, adding the PHP layer is definitely one extra hop, and it's expected to see some increase in the latency, end-to-end latency. However, that latency is very minimal with the proper routing between the Blade Runner service and PHP service. And in our case, these 2 layers happen to be in close regions in terms of the network topology. And that is going to not increase latency by a lot. It should be probably in a few tens of milliseconds. However, I should also say that previously, Blade Runner wasn't also self-sufficient. So Blade Runner, for processing all the streams, it couldn't do everything contained within Blade Runner. So still, we could see some Blade Runner to other services, like remote RPC calls, from Blade Runner to other external dependencies for different stream processors. It was just that these calls to external dependencies were not structured. So every stream processor would somehow get out of Blade Runner into some external services, and they incurred all those remote calls. And what we did was actually to put a structure, to put a format on all the Blade Runner to external dependency calls in the form of PHP standard events and actions, as we discussed in the event action Lambda framework.
Thank you for telling more about how you're making sure that these calls are staying nice and cheap when you're adding them in. And so I follow that up with another question about Blade Runner for Poya. How do you ensure that a noisy product does not impact other products' traffic, as we're adding in these calls?
Thanks for the question. So to add the question first, basically Blade Runner serves thousands of different products. And if the traffic goes up, Blade Runner starts to horizontally scale the number of hosts that basically process the streams. Now, if one of the products starts really using a lot of hosts, it can impact the other products. So that's a fair question in that perspective. And to avoid this from happening, I think generally we have two different methods to attack this. So one of them is by setting proper quota limits to avoid products from scaling up too much. And this is something that mainly is determined based on the product needs and also based on the constraints on the client side. The other way to address these noisy products is by having separate isolation or separate charts for different products. For example, if one of the product is very latency sensitive, we can have a dedicated set of pools serving only that products, just to reduce the interference between different traffics from different types coming into the Blade Runner.
Great. Thank you very much, Poya. Moving over to a different type of measurement, when we're talking about measurement for AI. Riham, can you tell us more about the benefit of using BPF for GPU memory profiling as opposed to the PyTorch memory profiler or others? What are some drawbacks?
Sure. So the biggest benefit that we think of is that it's really low overhead because it's running on the kernel level. It doesn't require any instrumentation or changes to the code. So it's kind of guaranteed to always reflect like the reality of what's really happening. It also can understand both CUDA memory and PyTorch memory. It's actually very flexible, so you can just tell it whatever events you're interested in, and it can profile that for you. It's also out of process, so that's another benefit where you can tell that it's not impacting the process. Like it doesn't have significant impact on the process performance or reliability. Where it doesn't, maybe where it lacks some of the features is it doesn't have the specific context of what's happening on the GPU. So it can tell you when you made a call to allocate memory, but it's not necessarily very good at telling you the state of the GPU memory. Or in the case of PyTorch, it can track the PyTorch mallocs and frees, but it struggles a little bit with getting some of the context that's like PyTorch specific operators, tensors, and so on. So we think of it as a very good tool for like high level continuous profiling. It can help you narrow down and figure out if there is a problem. But then a lot of times you would need to rely on one of the other tools to kind of dig deeper into the performance issues.
Thank you, Riham. That makes sense. And a quick question for Hao from the audience from Bestov. Is there any plan for releasing libasicmon as open source?
Yeah, thanks for the question and also the interest to libasicmon. So we do see as the demand of AI and accelerator space grows, there are multitudes of companies building accelerators today, but the accelerator monitoring interface lacks like standardization, which may add like additional engineering overhead as well as scalability challenge. And we believe libasicmon will be a good addition to the open source environment. So far, we don't have an exact timeline yet to share, but when we provide it, it could be either as a part of our open source Dynalog project, which we released last year, or it will be like providing like a very easy integration point to the open source Dynalog.
Great, looking forward to that, Hao. Poya, can you tell us, this is a question from Hikaj Mehra. How can viewers find out about the blog posts you've referenced in your talk?
Yeah, I think the blog posts are already posted on the At-Scale conference website. So if you go to the At-Scale conference, there is a blog section that you can go there, and then you will see all the blog posts for the presentations for today.
Great, thank you for that. And back to David Zhang from Alibaba and PolarDB. This is a question that's coming from Vipul Patel. How did you go about pricing the product for pay-as-you-go model, given that it's hard to predict capacity requirements in advance?
This is a great question, and I think the audience member keyed in on a challenge to all cloud services because people are coming to the cloud due to its elasticity, but it's challenging pricing. And that I do want to say that I don't have a complete answer as my day job is an engineer and I look at pricing as a product side problem. But I do think we do have data on capacity planning, for example. It's something that companies have been doing for years. We want to maybe model it and provide a tool in this area. And PolarDB has been in traditional price model for a while. So we have a lot of legacy capacity data. So if existing customer has been using PolarDB, there's a lot of history to go on. That said, the pay-as-you-go model is in early stages of deployment, and so there will be some experimentation and maybe adjustments as we go along. So thank you for this question.
It's definitely a difficult thing figuring out exactly how much capacity and how much it's going to cost with any project that we're on. And to ask you more about PolarDB, can you tell us more about the memory disaggregation and how it differs from general resource disaggregation approaches?
This is a great technical question, and indeed, in the field, there have been general memory disaggregation approaches implemented at the maybe kernel level, so that any application can use memory disaggregation transparently in some cases. So we've also looked into this, and the study is in the referred paper. We believe that our approach's strength is that it's tailored to the database application, and database is an important application in the cloud. So, for example, with the buffer pool memory, you have to redesign the LRU algorithm for remote memory and local memory. And in this case, our algorithm is the database specific LRU algorithm. It's not a general algorithm. So in that case, we can, it's tightly fit to PolarDB. That's, we think it's a strength. And I think in past work, there's always been this tension between OS general approaches versus database specific approaches. And we believe we follow the learnings from the past.
That's a great way to make things a little bit more specific for the scenario that you're operating on, especially with the web and the cloud being so database dependent. I have another question up here for Valentin, especially considering this is all about performance management. Can you tell us some of the examples and performance anti-patterns that are typically addressed with the observability solutions?
Yeah, thank you for the very good question. So there are many performance issues and they're quite diverse, but I can probably name a few common ones. We typically see data loading bottlenecks where either maybe data loaders are doing heavy transforms or they're not using sufficient workers or sufficient parallelism. We see also PyTorch code snippets. They tend to execute the same operations on small tensor slices. In those cases, we can either fuse them using Torch compile, or maybe we can explicitly modify the model definition code. We also see cases where there are expensive computations done on the host, and these ones block the accelerators and keep them idle. Then these are like major QPS degradation sources, but there are other common investigations that we do. For example, we look into how computation is being overlapped with communication, or we look at the imbalance between ranks. We check if hyperparameters are properly tuned, and for example, if the code makes a good use of accelerator memory. And these are like main categories, and after that, the performance issues become specific to the application, and in most cases, they require a specialized solution, so they cannot be properly bucketed. Yeah.
Thank you so much for sharing that with us. And that's a wrap for our Q&A on the performance management. Thank you so much for joining us, our experts, and your talks have been wonderful. And we are going into a short break, and then we'll be starting up with session 5, which is all about developer experience. Thank you so much, and see you shortly.